Here's the first section of Chapter 13 notes, talking about mirrors and reflection of light rays. First thing, electromagnetic waves. Electromagnetic waves are electric and magnetic field waves that oscillate outward at the speed of light. Two things that this is going to be dependent upon. If you're talking about the speed of light, then obviously we need to assess frequency and wavelength. This should be known from like chapter 11 and then again in 12 when we saw the wave speed equation of velocity equals frequency times wavelength. So what types of waves are electromagnetic waves? Well, if you look at this picture up here, guys, okay, if you look at this picture, it shows that the particles are vibrating perpendicular to the direction of motion. Well, if you're vibrating perpendicular to the direction of motion, then this would be an example of a transverse wave. So electromagnetic waves are transverse waves. Make sure you understand that picture, please. Next, what we have here is all electromagnetic waves move at the speed of light. This is a number that you need to memorize. 3.00 times 10 to the 8th meters per second. 3.00 times 10 to the 8th meters per second. We're going to be a little bit more specific with our equation this time around and say C equals frequency times wavelength. Whereas C is going to stand for the speed of light, more specifically, not just necessarily sound, but it will still be in meters per second. F is going to still stand for your frequency. Although frequency is measured in hertz, a hertz is also 1 over a second. That's why you have something in the denominator for the speed of light, meters per second. And then lambda stands for your wavelength, which is measured in meters. So with a specific type of photography, you can record how light stays in the air, for lack of a better term. This leads us to our first sample problem, which says the AM radio band extends from 5.4 times 10 to the 5th hertz to 1.7 times 10 to the 6th hertz. What are the longest and shortest wavelengths in this frequency range? Well, the first thing that we know is our first frequency of 5.4 times 10 to the 5th hertz, and our second frequency is 1.7 times 10 to the 6th hertz. Your constant is known and it will be applied to both scenarios, which is 3.00 times 10 to the 8th meters per second. So we want to solve for lambda 1 in meters and lambda 2 in meters, which is your wavelengths respectively. So C equals frequency 1 times wavelength 1, and then we'll use C equals frequency 2 times wavelength 2. C over frequency 1 equals lambda 1, so 3.00 times 10 to the 8th divided by 5.4 times 10 to the 5th. Plugging this into your calculator, you roughly get 5.6 times 10 to the second. You're looking at your sig figs, that's the correct number of sig figs. 5.6 times 10 to the second meters is lambda 1. Your second one, same, rearrange it. 3.00 times 10 to the 8th divided by divided by 1.7 times 10 to the 6th. That is going to give you about 1.8 times 10 to the second, which once again you do want two sig figs, so 1.8 times 10 to the second meters is lambda 2. Okay, so this would be considered the longest, this would be considered the longest, and the other one would be considered the shortest. Bigger number, smaller number. Here are your answers to 1 and 3. Remember, you are only doing the odds of 1 and 3 for practice A, B, and C for chapter 13.